Hey everyone, Mr. Allen. We're going to move on to probability now. Probability is kind of one of those topics that you have an idea about before you ever get started. We all kind of understand the general idea that probability of what probability is. People often say things like, "What are the chances of that happening?" "Oh, what are the odds?" "Oh, I can't believe such and such happened to me." If you play poker at all, for sure you're going to have the person kind of that freaks out when their pocket aces gets beaten by pocket fives. "Oh, what are the chances of that happening? I can't believe how unlucky I am." So we all have an idea of what probability means. We just don't have necessarily a great idea of how probability should be looked at, and we're going to start looking at that today. So probability, kind of by definition, is the percentage chance of something happening. The probability of rolling a 7 with 2 dice is 1 in 6, approximately 16%, 16.7%. Just to clarify a little bit, odds is a little different, although you'll hear people use them to mean the same thing. Basically, how they'll often say, "What are the odds?" Really, what they're saying there is, what is the probability? We won't worry too much about it at this point for sure. But odds is a ratio comparing how often two events occur. So the odds of rolling a 7 is actually 1 to 5, or 5 to 1 against. You look at the number of ways the positive can happen and the number of ways the negative can happen. So I can get a 7 in, it turns out, I can roll a 7 in 6 different ways. I can roll a non-7 in 30 different ways. So it's a ratio of 6 to 30 or 1 to 5. Now again, not necessarily important at this point, but just sort of understanding that mathematically speaking, odds and probability aren't necessarily exactly the same, although obviously in the end they represent the same basic ideas. So sort of looking at probability, again, sort of the idea is what's the percentage time that something occurs, with the understanding that, of course, kind of by random chance, things will or won't occur, but in the long run, we sort of always look at, in the long run, the chances are this is going to occur a certain number of times, or again, a certain percentage of the time. So if you're looking at flipping a die, for example, if you're looking at flipping a coin, for example, we know that I'm going to get heads or tails on the first flip. We know that I'm going to get heads or tails on the second flip. The chances, though, are sort of over time that will get that balance of maybe around 50% of the time heads, 50% of the time tails. That doesn't mean that I'm not ever going to get 3 or 4 heads in a row or 3 or 4 tails in a row. In fact, my guess is, I'm pretty good at this, I'm probably going to get 4 of the same thing in a row just by kind of running through it right now. So I'm just going to put on the magic fingers and see if I can do this. Here we go. Okay, so as I said, pretty lucky, just 4 in a row, happened to work out that way. Doesn't mean I'm cheating, just kind of, again, it's going to happen a certain amount of the time. And we've looked at this idea before of kind of looking at a tree diagram for counting purposes. And this is sort of, on my first flip, I could get heads or tails. If I got heads on my second flip, I could again get heads or tails. If I got heads again, I could get heads or tails one more time, and so on. And you sort of look and see that on this tree, I have a total of 8 different kind of a series of heads and tails that could occur. The probability then, if we wanted to look at that, of getting, let's say, 3 heads in a row, so that's this situation here. There's only one way out of the total number of 8 possibilities that gives me 3 heads. So the probability of getting 3 heads is 1 in 8. Likewise, the probability of getting 3 tails is 1 out of 8. But the probability of then getting either 3 heads or 3 tails, of course, becomes 2 out of 8 or 1 out of 4. Okay, so again, this is just kind of what probability means. This is in this case, the fraction of the time that I'm likely to get the same flip 3 times in a row if I do attempt to flip it 3 times in a row. This is the fractional answer. You could recognize, or you probably do recognize, that 1/4 is equivalent to 25%. which is also equivalent to 0.25. And any one of these is a legitimate way to represent a probability. So 1 out of 4 times, 25% of the time, 0.25 is my probability. The three are synonymous, and we'll be using all threes throughout the extent of the course. Similarly, rolling a die, sort of when I roll the dice, recognizing what we know here, there are 6 possibilities here, there are 6 possibilities here, and so from what we've seen before, that means there are 36 different combinations that can occur here of 1, 1, 1, 2, 2, 1, and so on. If we're looking, for example, then at what's the probability of rolling a total of 3, essentially what we're looking at is how many ways can we get the 3 divided by the total number of 36 possibilities that occur. Well, if we just kind of count up how many different ways we can get a 3, a total of 3 again, I could have a 1 on this die and a 2 on this die. I could have a 2 on this die and a 1 on this die. And I guess that's really it. So my probability of rolling a total of 3, there are 2 ways out of the 36 possibilities. And so the probability of rolling a 3 is 1 out of 18. Okay, and again, that's just kind of logic. I can count up how many options I have that will be successful in getting my total of 3, and I divide that by the total number of ways that I can get anything legitimate by rolling 2 dice. And so just sort of some key concepts here. By definition, probability is essentially the number of ways to get what I'm looking for divided by the total number of possibilities. So again, on the previous example, we had 2 ways that we can get a total of 3. We had 36 possible combinations that could occur, and so 2 out of 36. Just again, some other facts. The probability of anything occurring ever, anything that we ever think of, will occur between 0% of the time and 100% of the time. And so again, if we're thinking of in terms of just decimal values, anything from 0 to 1 is a possibility. In terms of percentages, anything from 0% to 100% is a possibility. And then a little bit of just kind of syntax here. The single quote beside an event. A is the event that we're trying to check when it occurs. And so this is the probability of A not happening, essentially. It's the probability of the opposite of A is what that little symbol represents. And so again, just sort of so that when you see that, you know that what it's asking is what is the probability of something other than A or of not A occurring. And then it should be fairly obvious once you kind of get the concepts down that the probability of something occurring plus the probability of it not occurring has to add up to a total of 1, or again a total of 100%. So if there's a 30% chance of it raining tomorrow, there has to be a 70% chance of it not raining tomorrow. Now that 70% chance could have sun, it could have cloudy, it could have snow, it could have sleet, it could have all kinds of things in there, but it's just not rain, essentially. So a 30% chance of rain and a 70% chance of not raining. And of course, that comes out to the 100%.